Hey guys, welcome back to another set of papers. In this one, we'll be looking to tackle the Jan 2019 IGCSE for Edexcel. And in particular, this is the 1HR. If you guys got any other requests for other different paper series, please let me know. I'm going to start putting up polls soon so you guys can actually choose which papers you want me to do next. And we can talk about it as well as a community. But anyway, we're going to jump straight into the question now, okay? Alright, number 1. Show that 1 2/3 plus 2 3/4 equals 4 5/12. Okay, so obviously they want you to do this without your calculator, but of course you can always abuse your calculator in some areas. What I personally recommend is literally input this in your calculator, so using the mixed fraction button, 1 2/3, which will give us 5/3. Again, this is just convenient. 2 3/4, which will give us, let's see, 11/4. I mean, if you don't want to do that, you could always do 1 times 3 and add plus 2, which will give us 5. Or 2 times 4, which is 8, plus 3, which will give us 11. You can do it manually, but I think it's best to just use a calculator. And now lastly, all we want to do is make common denominators. Because we know the end goal is 12. To get the left fraction to 12, you're going to want to multiply up and down by 4. To get the right fraction to 12, you need to multiply up and down by 3. And doing so, on the left hand side, if you times up and down by 4, you're going to get 20 over 12 plus, times in the right side by 3, 33 over 12. And now essentially you're just going to add up the top half, which will give us 53 over 12. And of course, if you want to convert this to a mixed fraction, well, you don't even have to bother. Just copy the answer. So it'll be 4 5/12. Easy. Okay, number 2. So there are 60 children in a club. Okay, now this is something different. In the club, the ratio of the number of girls to the number of boys is 3 to 1. So essentially, you always add up how many parts there are. So there's going to be 4 parts, because that's 3 plus 1. And now this tells us, in terms of the 60 children, that 3 out of the 4 parts represent girls of the 60 children. So we say, all right, 3 out of 4, so 3/4 of 60 are girls. And 3/4 of 60 is 45. So that's 45 girls. And that leaves us with 1/4 of 60, which is going to represent the boys, which is 15 boys. If you want to work this out like easy in your calculator, just put 3 over 4 times 60, if you're not too sure sometimes. Now, let's follow this up. On the next line, it says 3/5 of the girls play a musical instrument. So 3/5 of the 45 play a musical instrument. So 3/5 of 45. Again, you can put this in a calculator, and this should give us, I should do this mentally. So it should give us 27 play music, whereas 4/5 of boys, and that's 4/5 of 15. So 1/5 is 3 times 4, which is 12. So 12 play musical instrument. Now it tells us here what fraction of the 60 children play musical instrument. So first things first, how many play musical instrument altogether? Well, if you add up these two numbers, you're going to get 39 kids play musical instrument. Out of 60, so 39 out of 60 is literally what they're looking for. Now, you should probably simplify this, and if you do, you're going to get 13 out of 20. Alright, number 3, guys. So in triangle PQR, so that's basically the whole shape across, S is the point on PR such that the angle RSQ, so PR is this long line here, and angle RSQ, so star RSQ is right angled, so it's 90 degrees. Now it tells us 3 other pieces of information. You got RQ, which is here, 14, RS, which is down near 10, and PS, which is, or SP, which is 5. Okay, so work out the length of PQ. In other words, work out this unknown length here. Now the best way to do these kind of questions, and if you look at it carefully, we've got 2 right angle triangles. So you could just literally use Pythagoras' theorem on the first right angle triangle to work out this unknown length here, and use it again to work out the second triangle. So let's take out the right triangle for a second, yeah? We're just literally going to use Pythagoras on this one. Now to use it, the formula is so easy. It's always a squared plus b squared equals c squared, where a and b are the 2 shorter lengths and c is the long hypotenuse, in other words the diagonal length, opposite right angle. So now putting this in the formula, we're going to have y squared plus 10 squared must equal 14 squared. And all you guys got to do is just minus 10 squared across. So y squared equals 14 squared minus 10 squared, and then square root your answer to get y. And when you do that, you guys should get y equals 4 root 6. Now I'm just going to leave it in this form because that's what the calculator told me, yeah? So we won't change that for a second. And now we repeat for the second part here. So now we got x squared, so we can say that using the same idea. So you got a squared, which we can say is 5, so 5 squared plus our y squared, which is 4 root 6, so 4 root 6 squared must equal x squared. Again, literally put this all in the calculator and then square root to find x. So because you have 4 root 6 in your calculator ready, just use that answer button, yeah? So you can say answer squared plus 5 squared, and then square root that, and you should get a nice 11. And that's it, guys. That's literally the solution. So we've got A, B, and 40 are 4 numbers. So we don't know if they're in order, but it tells us now that A is the least number and 40 is the greatest number. So yeah, we can assume that all these numbers are going in order, where the first two A's are the smallest, then it's B, then it's 40. All right, next bit. So the range of the 4 numbers is 14. Range tells us the difference between the highest and the biggest and the smallest value. So in other words, the difference between the highest, which is 40, and the difference between the smallest, which is A, is going to equal 14. Now, that's easy to solve, yeah? It's literally, you can just do in your calculator, 40 take away 14, and that should give us 26. So A is 26. That's cool. The median of the 4 numbers is 30. So median is basically the number bang in the middle. So in other words, here. So between A and B. So to make it very easy, a little trick is that you just pick the 2 values. So in this case, we're concentrating on A, which is 26, and B. And we know that it's somewhere in between them. The best way to do this is to basically add these 2 numbers, half them, and you should get the value in between, which is 30. Now you just solve this equation. And to solve it, you firstly clear the fraction, so times 2 across, so you get 26 plus b equals 60. And now you just do 60, take away 26, and you're going to get 34. And that's it, guys. That's literally your A and B covered. So that Shanghai maglev train, this is a fast train, takes 8 minutes to travel a distance of 30.5 kilometers. Okay, that is quick. Work out the average speed of this train. Give your answers in kilometers per hour. Now, before we do anything, let's write down the speed distance time formula. So we say that the average speed equals distance over time. Now this is easy. Now all we literally do is put the distance, which is 30.5 kilometers, on the top, and the time. But be very careful here. Notice how they want kilometers, which we have, per hour, which we don't have. We have 8 minutes. So to change 8 minutes to the hours, you can literally put on the bottom half of the time as 8 over 60. Because to convert it to hours, just divide it by 60. Now in your calculator, literally put all of this at once. Don't bother simplifying. And if you do that, you're going to get exactly 228.75 kilometers per hour. And that's what they want. And you get all that space for 3 marks. Okay, number 6. So the diagram shows the triangle PQR. Okay, and this is all done algebraically. Okay, in the diagram, all the angles are in degrees. So it tells us that the length of RP is equal to RQ. Now when they tell you this means that these two are isosceles. So we're dealing with an isosceles triangle which has equal lengths and equal angles. Okay, which is important. So that means 3x plus 10 equals x plus 52. So I'm going to put a little equal sign there, yeah? Now find the value of y. Show clear algebraic working. Okay, so this is one of those kind of problems where they tell you to find y, but secretly you need to find the value x first. So let's equate these two. So we've got 3x plus 10 equals x plus 52. And then we just solve to find x. So minus x across and minus 10, you're going to get 2x equals 42. Half of this, x equals 21. So that's nice and easy. So what you want to do here now is that since you know the value of x, which is great, so x is 21. So we're going to have this. Actually, no, the good thing about this one, because it's isosceles, if you work out one of the angles, you automatically have the total value of the other one. So working out the angle of Q, we know x, we can just put x back in, so it'll be 21 plus 52. That's going to give us 73 degrees. And of course, this is also 73 degrees. If you're not sure, just replace x with 21 for both of them and you should get the same result. So that's fine. Now we know that all angles in a triangle must add up to 180. So we're going to have 73 plus y must be 180. And now we just solve to find the value y. Adding up two 73s, that gives us 146 plus y is 180. And then minusing 180 from 146, you should get y, which is 34 degrees. So this angle is 34. Okay, number 7. So the diagram shows two water towers in Kuwait. Whew, Kuwait, I used to live here. Beautiful city, by the way, guys. So you got Tower A, which is 187 meters, and the real height of Tower B, which is 147. So just a bit taller, sort of. Now Ahmed makes a scale of both towers. The height of Tower A on the scale model is 90. So we're trying to say that this scale model is something you write on paper. So you're sketching this, which is probably here, 90 centimeters. In reality, it's actually 187. So you can kind of tell if you compare the real height to the scale, and we should always do this, real to scale, we can have 187 meters over 90. This will tell us how many times bigger it is in raw units. And on the calculator, this is about 2 point something, yeah? Something really big, about 2 times bigger. Now, the question wants us to work out the height of Tower B on the scale model. So since we know the scale factor between the real height and Tower A, we can just use the scale factor of 2 point something and divide that from 147. So for Tower B, we can say that the scale model is 147 divided by the scale factor, okay, which is 2 point whatever on your calculator. What you guys should do is never round up the value, by the way. You probably notice that you get a really bad answer. So if you're going to divide it, divide against the whole fraction. And if you do that, you get an answer of 70.7 and then 486 ... Now they want our answer correct to the nearest centimeter, so round it up, yeah? So 70.7 rounds up to 71 centimeters. And that's it, guys. That's all you do. Number 8. Alright, guys, this is literally my favorite question ever. So here we need to solve the simultaneous equations, okay? So we've got two pairs, and the idea is, and then this is just one method, is to make one of the equations, one letter from another equation a subject. In this case, I'm going to take the second equation, so this one here. And then you're going to substitute that equation into the first equation or the other equation. So let's look at the second for a moment, yeah? I'm going to make x a subject. So I'm going to plus 4y across. So we're going to have x equals 4y plus 9. Now the reason why this is good is that once you obtain a value for y, you plug it here and you automatically obtain a value for x. We're going to come back to that later, yeah? So now using this expression for x, we're going to substitute this into the first equation. In other words, you're going to replace this x with 4y plus 9. So this equation here becomes 4 times 4y plus 9. So remember, x became that. And copy the rest of the equation. So plus 2y equals 9. Now all you do is just expand and solve for y. So expanding the bracket, you're going to have 16y plus 36 plus 2y equals 9. 16y plus 2y is 18y. Minus 36 across, so 9 minus 36 is minus 27. And then dividing 18 across, you're going to get minus 3 over 2 or minus 1.5. Both is good. And now thankfully, you literally just substitute these values into this equation over here. So you're going to have basically x equals 4 times, I'm going to pick the decimal, minus 1.5 plus 9. And then when you put this in your calculator, you're going to get a simple 3. So the answers are going to be x equals 3 and y equals minus 1.5. So it tells us that we got n equals 480 times 10 to the power of 9. Now they want us to write this figure here as a number in standard form. Now this does kind of look like in standard form in a way. The only problem is that it does not allow us to have 3 whole digit numbers. We can only have 1 whole digit number with decimals, which is fine. So we have to somehow convert 480 into standard form. So let's do it. To convert any number into standard form, we always take the first digit, so in this case 4, put a point and then copy out any possible non-zero digits like 8, right, times 10 to the power something, and then we just count how many digits are after the first number. So in this case we've got 2 digits, 80, so it'll be power 2. Now for the whole equation here, for n, because we have an additional 10 to the power 9, you essentially be adding the powers, because when you multiply two terms with the same bases, you add the powers. So we say therefore n equals 4.8 times 10 to the power of 11. And that's it, all done. Now for b, write n as a product of powers of its prime factors. Show you're working clearly. Okay, so in this case, my usual tip for separate these numbers, and whatever you do not multiply them head on, or you're going to be breaking down really big numbers and it'll take you a while. So my tip, let's do 480 first, yeah, and then do 10 to the power 9 later on. Now let's break it down into prime factors. So my first move would be to realize that there's a 0 at the end, so I can divide it by 10. So it'd be 48 and 10. And then breaking down 48 into 2s, we've got 2 times 24. 24 goes down to 2 times 12. And then, 12 becomes 2 times 6. And lastly, 6 becomes 2 times 3. And when you've broken everything down to its last legs, you just circle them. So 2, 2, 2, 3, and 2. And as for the 10, we break that as well. It becomes 2 and 5. So that's it. So now we've more or less found the prime factors of 480. Now how about 10 to the power 9? So there's a little trick here. The trick is to really ignore the power. And it's to rewrite 10 to the power 9 as 2 times 5. We could write this in terms of powers. So we're going to have 2 to the power 9 times, or ignore that, 5 to the power 9. And that's it. We've more or less broken them down. Because we can see that we're going to get 9 sets of 2s and 9 sets of 5s. Now finally, they want us to write n as a product of its powers. So in other words, we need to combine everything together. So this is the part where we just literally count them up. So starting with the 2s, we have 1, 2, 3, 4, 5 on this side. And we got 9 on this side. So collecting them, we're going to have 14 2s. So we have n equals 2 to the power 14. Now we look at the next digit, which is 3, and we only have a single 3, so times 3. And as for the 5, we got 1 here and 9 here. So altogether we got 10. So 5 to the power 10. Now for C, we need to find the largest factor of n that is an odd number. Well, we just literally found all the possible prime factors right here. And the only possible odd numbers would be 3 and 5 to the power of anything. Now if you're not sure why that's the case, we can pretty much ignore the 2 to the power 14, because anything that's times in by an even number is going to be even. When you times two odd numbers, you get an odd number. Okay, that's just a little thing to take note of. So odd times odd gives us odd, but anything times an even will make it even. So we're left with essentially 3 times 5 to the power 10, and that is the highest possible odd number you can make. And that's it, guys. That's this question done. All right, number 10. So the shape shown shaded in the diagram, well, that's a lot of S's, is a region between 2 semicircles. Okay, so we've got 2 semicircles, all right? The diameter of the outer semicircle is 12, so this means the whole thing. By the way, when you have circles, it's always best to try and get a radius, yeah? So if the diameter of the outer semicircle is 12, then half of it will give us the radius. So the radius for the big semicircle is 6. Now, the next one's a bit interesting. The shape has a constant thickness of 2 centimeters. Notice it's just this length here. Now if we think about it, it's going to be 2 centimeters all the way around. So essentially from the center, which would be here, if this whole thing is going to be 6 and this part is 2, that means this gap here must be 4. So we actually have a white semicircle with radius 4. So we're going to keep that in mind, yeah? The white bit will have a radius of 4. Okay, next, calculate the area of the shape. Give your answer as a multiple of pi. Okay, so we basically, the main idea is that we want to firstly find the area of the whole semicircle, assuming there's no white bit, and subtract it from the smaller semicircle. Now the area of a semicircle, so let's say total area, the area of a semicircle is actually the area of a circle, which is pi r squared, and then halved. Okay, so to find the total area, it's going to be the area of the big semicircle, so it'll be pi, and this time r is 6 squared over 2, minus area of the smaller white region, which is pi 4 squared over 2. And then when you put this in the calculator, thankfully your calculator give us an answer in terms of pi, and it'll give us 10 pi. And that's it. This question is done. Alright guys, number 11 now. So there are 12 boys and 8 girls in a class. The boys and the girls have some coins. Alright. Now the mean number of coins that the boys have is 5.5. Let's keep that in mind, yeah? I'm going to call B for boys, and this little bar means mean. So the mean is 5.5. Now, the girls have a total of 18 coins. Notice that they never say the mean here. Work out the mean number of coins that the 20 children, i.e. all the boys and girls, have. Okay, so this is one of those examples of a weighted mean equation. Now there's a nice way to represent this. We usually say this. We say that firstly we got, let's work with the boys, the number of boys times the mean must plus the number of girls times its mean must equal the total number of students times the mean of the total number of students. So this kind of formula, you know, overall explains this entire equation. This is literally the weighted mean equation. So we can think of it as the number of boys plus the number of girls give us the total number of students. If you multiply the means next to them, you're going to get this exact relationship. So now all we have to do really is just plug everything back in. So we got 12 boys, so it's going to be 12 times 5.5 plus we have 8 girls. Now we don't have the mean, but it's easy to find the mean. If you've got 8 girls in the class and altogether there's 18 coins, the mean is literally going to be 18 over the number of girls. And you can just put that in. Like, I wouldn't bother working out here because you can put in a calculator. And this will give us the total number of children, which is 20 times this mean. And that's what we're trying to find. We're trying to find this t-bar, yeah? So in your calculator, rearrange, put all of this in, and then divide it by 20. And when you do that, you should get an actual mean of 4.2. And that's it, guys. That's this question done. Okay, number 12. So here are the first 4 terms of a sequence of fractions. Okay, so it looks to me that the numbers on the top half are going up in ones, and the bottom we have odd numbers going up 2 each time. Okay, so the numerators of the fractions form the sequence of whole numbers 1, 2, 3, 4. The denominator, the bottom half of the fractions, form the sequence of odd numbers. Okay, just like we said. Now A, write down an expression in terms of n for the nth term of the sequence of fractions. Okay, so what this actually means that we need to find the nth term for the whole numbers and an nth term for the odd numbers, and then put them on top of each other as a fraction. So to do it simply, for the whole numbers, and I'm going to do this really quick and easy and fast, and that'll be the top half. We ask ourselves firstly, what's it going up in? Well, we know it's going up in ones, and then we ask ourselves secondly, what is the term before 1? Because we need to know what the 0th term is. So if it's going up in ones, the term before 1 must be 0, so it'll be plus 0. Now for the second sequence, we do the same thing. We ask ourselves, what's it going up in? Well, it's going up in 2's, so it'll be 2n. And then the term before 1, before the first term, and you can only get that if you go back by 2, because everything's going up in 2. So if you subtract 2 from 1, you get minus 1. And that's it, guys. This is literally your expression. But simplifying this, of course, 1n plus 0 is just 1n, and 1n is just practically n. So it'd be n over 2n minus 1. And that's it. That's your expression found. Okay, part B. So using algebra, prove that when the square of an odd number is divided by 4, the remainder is 1. If they use the word even number, by the way, an even number is always going to be 2n. Whereas an odd number, and this is just it's a clear definition, yeah, be 2n minus 1. So these are properly defined here, so there is no other ways to write them. Okay. Now to prove this, it says prove that when the square of an odd number is divided by 4, so we need to take an odd number, do the square of it, and then divide it by 4, we get a remainder of 1. So alright, let's try this out. So all you want to do is literally expand this term. So 2n minus 1 is literally 2n minus 1 times 2n minus 1 over 4. Now multiplying out the bracket using FOIL, in other words, you do 2n times 2n, 2n times 1, and so on. You're going to get 4n squared minus 2n. Then you got minus 1 times 2n and minus 1 times minus 1. That gives us another minus 2n plus 1 all over 4. So we're going to have 4n squared minus 4n plus 1 over 4. So we're going to have 4n squared over 4 minus 4n over 4 plus 1 over 4. Now what happens here? So when you divide this by 4, these two cancel out, so 4's cancel out and 4's cancel out. So we're left with n squared minus n plus a quarter. Now, what does this actually tell us? Well, this tells us clearly that firstly, you get a whole number here when you divide it by something, and you're left with a remainder of 1 when you divide by 4. And that's it. So really, all they really wanted to see is that you get a quarter, because 1 over 4 is a remainder of 1. Okay, this is the same definition. Okay, number 13. So a curve C has equation given as follows. Find dy of dx. Okay, so this means differentiate the equation. And differentiating is so easy, by the way, guys. This is what you get. So to differentiate, all you do is look at the power and drop it on the ground. So x to the power 3 becomes 3. x, and then you subtract the power by 1. So 3 take away 1 is 2. For the second term, you drop the power 2 in front, so you get 2x. Subtract 2 by 1 and you get 1. So just 2x to the power of 1, which you can leave like 2x. Next one is 8x. Now, if you imagine for 8x, you got a power of 1 here, yeah? If you drop the 1 down, it'll be 1 times 8, which is 8. And then you're left with 0. Now, anything to the power 0 is actually 1. And then you basically got 8 times 1, which is 8. Or a nice way to memorize it is that if you're left with the term x, it always vanishes when you differentiate. And now next last bit, when you differentiate a constant, because there's no x attached, it's going to be 0. That vanishes. So you're left with basically this equation here. Okay, part B. So the curve C has 2 turning points, and the curve C is this one here. Work out the x coordinates of the 2 turning points. Okay, so a turning point is literally when the graph turns. As simple as that. Because we've got a cubic graph, and it's cubic because the highest power is 3, it looks a bit like this. So the graph looks a bit like that, something like that. We don't know how exactly, but like that. And we know it turns at 2 points, some point here and some point here. Now, one interesting thing about this and how it links to dy dx is that when you have a turning point, this means that at this point exactly, we can see that the gradient is actually flat, it's 0. And dy dx is literally the gradient expression. So we say, all right, at these 2 points, we must have a dy over dx equal to 0, a flat gradient. So all that essentially means is that you equate your dy dx equation over here to 0 and solve it like you would for a normal quadratic equation. And that's it, guys. That's literally all you do. So solving this quadratic equation, I mean, we just use the standard quadratic formula. So let me change the color pen. We're going to have x equals, so minus b, so b, actually let me write the whole thing, minus b plus minus the square root of b squared minus 4ac over 2a. And therefore x is going to equal, so minus b, so b is negative 2, so it'll be plus 2 plus minus the square root of b squared, which is minus 2 squared, which is 4, minus 4 times a, which is 3, times minus 8, which is c, over 2 times a, so 2 times 3. That's it, guys. And when you put this into your calculator, or if you use a calculator that can solve quadratics, you should get 2 solutions. One of them being x equals 2, and the other one being x equals minus 4 over 3. And that's really it. These are your 2 x coordinates. So we can say that one of the turning points was here, which is probably x equals 2, and this one here, which is probably x equals minus 4 over 3. If this was the graph, the xy axis. Anyway, let's do part C. Show that the x-axis is a tangent to curve C. Okay, what it's trying to say here is that if you plot this on a graph, let's just visualize for a second. It could be one of 2 scenarios. We have a turning point which occurs somewhere and it probably bounces at some line. Let's say it bounced here. Or it could have been like this. One of the x coordinates probably bounced here and then went up. Now a tangent is when you hit something at exactly one point. In other words, we're treating the x-axis as the tangent itself. So we're going to test whether one of these x coordinates will give you a y coordinate 0. So yeah, sorry, quick recap. When you get to prove something is a tangent to the x-axis, we need to show that it bounces on the x-axis. And if it touches the x-axis, that automatically means that the y coordinate is 0 because it's on the x-axis. It's right over here. Or right over here, which is also y equals 0. Anyway, let's plug in both of these coordinates, yeah? We're going to plug into the curve of y, which is over here. So we're going to say, all right, at x equals 2, if you plug it in, it will be, for example, 2 cubed minus 2 squared minus 8 times 2 plus 12. And if you did that, you'll get y equals 0. And yet, actually, this is your solution. If you get 0 as a y coordinate, it means that you're on the x-axis. However, if you plug in the other x value, which was what? Minus 4 over 3. If you plug this into this equation, you actually end up with a result of something like 500 over 27. Nope. And this is clearly not on the x-axis because it's all the way above somewhere. And that's it, guys. That's literally all they want. So your solution would actually be when x equals 2, y is 0. So that is the x coordinate they want. X equals 2, y equals 0. Now, and that's really it. All right, number 14. So a cumulative frequency diagram gives information about the values in thousands of euros of 120 apartments in 2015. Okay, so this means that, for instance, as the value of the apartment goes up, then we're accumulating the number of apartments. So this means if you're counting every single apartment, all 120 of them, they add up to 100,000 euros. Okay, so A, find an estimate for the number of these apartments with a value of 80,000 euros or less in 2015. So we just put our mouse on 80, scroll up, and hit somewhere around there. So I'm just going to zoom in a bit, guys, yeah? So, I don't know, like, what do you guys think this is? It's about over here, isn't it? I think that's about, and it looks like it's going up in 2, so it'll be 92, 4, 6. So I'll say about 96. Would you say 96? Yeah, 96. All right, next one. So the table gives information about the values in thousands of euros of the same 120 apartments in 2018. So it's literally different, comparing ones from 2015 now to 2018. Okay, so according to this data, it says, for example, let's look at the second one. It says up to 40,000 euros, there are 15 apartments that cost that price. Whereas up to 120,000 euros, there's exactly 120 apartments. So it goes up a lot now. Now on the grid opposite, so I mean opposites, I mean where? Alright, so it's probably before it. On the grid opposite, draw a cumulative frequency diagram for this information. Alright, this is very easy. You just treat this like coordinates, yeah? So remember, if you recall, the cumulative frequency is going upwards, so it's on the y-axis. So these are literally coordinates, and this would be the x-axis. So for instance, for each point, we can say up to 20, which is the x-coordinate, we have a cumulative frequency of 0. Next one would be 40 to 15. And it'll be all the way to up to 120 and 120. So that's quite straightforward. So let's do a few of them, and then I'm going to quickly time skip most of them. So let's look at 20 to 0. So it starts from here at the same place. Next one would be 40, 15. So 40, 15. So again, that's 10. So actually, it's the same place. 60 to 44. 60, 44. So actually, 44 is around here. Okay, now it changes up. That's it, guys. That's literally all of them. So now all you want to do is literally make a smooth curve if you can, which I definitely can't. So it's the same here, but then all of a sudden it deviates up to here, and then it goes up more. So yeah, it's kind of hard to draw curves sometimes, I admit. So whatever you do though, do not use a ruler. Okay. Anyway, it looks a bit like that. You know, I'm not gonna lie, it's not perfect, but it does the job. Now, part C. Find an estimate for the increase in the median value of these apartments from 2015 to 2018. That's an interesting question. So literally just find the median for both of them and see the difference. So we could say, all right, the median is literally the middle person. So if you've got 120 apartments, the midpoint would be the 60th apartment. So you half the value. So we could say at 60, at 2015, the value was somewhere over here. And in 18, or the year before, it's over here. So where's the difference here? So this value represents, let me see, this block over here between these numbers, yeah? So you got 50 here, 52, 54, so about 55, I'd say. And over here, which I'm probably wrong, it's around this value here. So it's just before 70, about 70, 69, about 68, 69, yeah? I don't even know. Somewhere between these two. So the change will be the difference between these values. So it'll just be for, I'm just going to use the value 68 here. So it'll be a difference between 60 and 55, which is going to be 13. So that would be the answer. So this answer at the bottom is 13,000 euro increase. Okay, so number 15, A. Simplify 3x squared y to the power 5, all of it powered by 4. When you have something like this, it's so easy. All you literally do is distribute the power 4 to everything. So we're going to have 3 to the power 4. X squared already has a power, so it'll be 2 times 4. Y has a power, so it'll be 5 times 4. And then you just simplify this fully. So 3 to the power 4, and you put it on your calculator, which will give us 81. X to the power 2 times 4, which is 8, so x power 8. And as for y, it's just 5 times 4, which is 20. And that's it, that's this one done. Now for B, expand and simplify 4n times n minus 3 times n plus 5. Right, so to start with these kind of questions, every time you've got brackets involved, you work with the brackets, yeah, and leave everything else. So right now, let's just ignore the 4n, yeah? Now to expand the double bracket, it's the same as always. So do n times n times 5, and then minus 3 times n and minus 3 times 5. So let's just keep 4n outside for a second, yeah? So now we've got n times n, which is n squared, n times 5n, which is plus 5n, and then you got minus 3 times n, which is minus 3n, so you got plus 5n, minus 3n, and lastly, minus 3 times 5 is minus 15. Okay, now all you want to do is firstly collect like terms before you deal with the 4n, so it'll be 4n times, and then you got n squared. Now these two here combine to make a positive 2n, because 5 take away 3 is 2, minus 15. And now you just multiply everything by 4n, so it'll be 4n times n squared, which is 4n cubed, 4n times 2n, which is 8n squared, and lastly 4n times 15 is minus 60n. And that's it, that's this one done too. For c, factorize 4c squared minus 9d squared. Now you have to literally spot this, because you probably realize that firstly there is nothing in common between c and d, or 4 and 9. But you have two things in common. You have firstly, they're both square terms. You got 4, which is a square number, c is squared, 9 is a square number, d is squared. So in this case, we need to use a method known as dots, which is the difference of two squares. And difference two squares means you can factorize them into double brackets. Now to get the answer, easy. 4c squared, you just have to square root each term. So square rooting 4c squared will give us a 2c. And then square rooting 9 and d squared will give us a 3d. And then you just put plus and minus. Okay. As for d, simplify fully x squared minus 7x plus 12 all over 4x minus x squared. Okay, so in this case, you would have to factorize the top half separately and then the bottom half separately. So let's look at the top half first, yeah? So the top half is actually a quadratic equation. And the way that works is that you can factorize into double brackets. And because you work with x squared, it's going to be x on both of them. Okay? Now, to figure out what the rest of the terms are, we just need to ask ourselves, what two numbers multiply to make a 12? Okay? So let's go ahead and write a list. So you can have 1 times 12, 2 times 6, or 3 times 4. Now, one of these pairs will also give us a sum or difference of a 7. Now, looking at numbers, only 3 and 4 can make a 7. And how to get minus 7? Well, you need to do minus 3 minus 4. And that gives us a minus 7. And yeah, that's the top half done. Now, as for the bottom half, to factorize 4x minus x squared, you look at both of them and they both have an x. So we can take our x from both of them, so divided by x, and you're left with a 4 minus x. And yeah, looks like we're actually almost done. But the only weird thing now is that we got x minus 4 and 4 minus x. Now the cool thing is, on the bottom half, what you could actually do, you could literally, like there's a little trick here. If you factorize a negative sign, then this becomes negative, this becomes plus. It's a little math trick. And what you can really say is that this is basically x minus 4 now. And now it's x minus 4, you can actually cancel down. So these two can go. And when you do this, you're going to get something like x minus 3 over minus x. Okay, number 16. So there are 12 bees in a bag. Now 7 out of the 12 are red, 3 out of the 12 are green, and finally 2 out of the 12 are yellow. So when you do probability questions, always make sure you note down the probabilities of every single possible scenario, like I did over here. This will literally help you guys for the later questions. Now, next bit. Lucy takes at random a bead from the bag and then keeps it. So that means the 12 will drop to 11. Then Julian takes at random a bead from the bag as well. Now work out the probability that they each take a yellow bead. Alright, so this is easy. So this is the probability of Lucy taking yellow first and then Julian taking yellow second. Now the probability of taking yellow first is, of course, you got 2 beads, so 2 out of 12. Now since Lucy keeps the bead, there's only 1 left and you now got a total of 11 beads in the bag. And this is simple probability. You literally just put this in a calculator and you're going to get a simplified answer of 1 out of 66. Okay, done. B. Work out the probability that the beads that they take are not the same color. Okay, so this is literally one of those combination questions, yeah? So we have to think about all the different combinations you can get. So for instance, you could firstly take, what colors we have again? So we've got red, green, yellow. So you could take a red bead first and then take a green second, or you could take a red bead and then take yellow. And this can extend to other ones, yeah? You can take a green bead and then a red, or a green bead and then a yellow. And of course, you can also take a yellow first, then a red, and then a yellow first or a green. So you actually have 6 different probabilities. Now, thankfully, a lot of these you can see are repeated, like red and green, or green and red and yellow, yellow and red, or yellow and green, green, yellow. So naturally, you can just work out 3 of them and then double your answer because to get the same amount. Now, to get red and green, so we'll do some of these in steps. So red, we got 7 out of 12. So we got 7 beads which are red. To get green, we got 3 of them, and there's 11 beads left altogether. To get red and yellow, again, red is 7 out of 12. And to get yellow, there's 2 yellows, and you got 11 left, so 2 out of 11. So what I'm going to do, guys, I'll just do 3 of these, and then we're going to total them up and then double it. Now we did red and green, red and yellow. Let's do, which one? Yeah, green and yellow. That's the only one left. So to do green, yellow, for the greens we got 3 out of 12 in the bag, and yellow we got 2 out of 11 left. And that's it. So now in your calculator, put this inside, plus this result, plus this result. So, and once you do that, you must then double your answer by 2 to account for like the other ways of doing it. And when you do that, you'll get a final probability result of 41 out of 66. Okay, number 17. So here we're given a solid sphere and a solid cylinder. Now the radius of the sphere and the cylinder are both r centimeters, but the height of the cylinder is 2r centimeters, so twice the radius. Now the total surface area of the cylinder is given as k pi. Now quick recap. Surface area is literally the area around the entire shape. Now if we look at the cylinder, for instance, we have 3 different segments. We got the base and the top bit, which are both circles, by the way, and then we got the curved surface area, which thankfully they give us a formula in the front of the book. Now just labeling each bit. So this bit is the area of a circle, which is pi r squared. This bit is the area of a circle again, which is pi r squared. Now the curved surface area is actually 2 times pi r times the height. So in a way, it's literally the circumference times the height. That's how they calculate it. Now we're given everything. Because the radius is r, we don't actually have to change these formulas. But because we know the height, which is 2r, we can update this one here. So it'll be 2 pi r times 2r. Now you can just collect the numbers. So 2 times 2 is 4, and then you got pi, and then you got r times r, which is r squared. So this is going to be literally the curved surface area bit. Now they tell us that the total surface so now they tell us that the total surface area is k pi. So in other words, if we add up all these surface areas, so we can add up pi r squared, another pi r squared, and now 4 pi r squareds, we're going to get 6 pi r squareds. And this is going to equal to k pi. Now looking at both sides, well, they both got pi, and we can just knock them off right now, divide by pi, and it tells us that k equals 6r squared. And that's it. That's literally k found. Show that the ratio, which is the total surface area of the cylinder to the total surface area of the sphere, is the same ratio as the volumes of both shapes. Alright, so we've already found total surface area of the cylinder, which was 6 pi r squared. So that's quite easy. Now, as for the total surface area of a sphere, they actually give you this in the front of the book, which is 4 pi r squared. Okay, so that's fine. So we put that here as well. Now, just simplifying this ratio for a second, you can literally just cancel pi r squared on both, and you got now 6 to 4. And then dividing that again, you're going to get 3 to 2. So that's literally the ratios fully simplified between both. Now we're trying to do the same for the volume. So let's do it. So the volume of the cylinder is actually given as well, which is supposed to be pi r squared times the height. And the volume of the sphere is also given to be 4/3 pi r squared cubed, or pi r cubed. Now height, again, we know what it is. Height was 2r. So let's put that in, yeah. So we're going to now have pi r squared times 2r proportional to 4/3 pi r cubed. Now just simplifying this bit, again, you just stick 2 in front times the r, so you get 2 pi r cubed proportional to 4/3 pi r cubed. And now cancelling all the like terms like pi r cubed on both sides, you now got 2 to 4/3. This is actually not such a difficult question. And now, oops, fraction. Now all you want to do is times 3 across to clear the fraction. So you got 6 to 4. And then simplifying this by halving it, you're going to get 3 and 2. Done. And then you got the same ratio. Show that this third fraction can be written in the form like this, where n is an integer. In other words, a whole number. Show you working clearly. Now, the cool thing about these questions is that you can actually right now throw this in your calculator. If you put all of this at once, you're going to get a result of exactly 2 plus root 2. Now, this is what they want you to have. But to get to this step, you need to show enough evidence that you got it. So that's what we're going to do. We're going to pretty much show enough tricks to get you the marks every time. Now, for third problems, the common idea is that you would always need to rationalize. This is literally the common idea. When you have a fraction and they give you a solution which is a non-fraction, you would have to somehow clear the thirds in the bottom. Now, to do that, it's super easy. Just copy the whole fraction and then always multiply by something known as its conjugate, which is the opposite of the denominator. So if you got root 8 minus 2, we want root 8 plus 2. Same goes if it was a plus here. If it was root 8 plus 2, then you can times up and down by root 8 minus 2. So let's copy the same thing here, yeah? Now all you want to do is literally multiply this head on with the left side of the fraction. So you're going to have root 8 times root 8, which is a whole 8 by the way. 2 thirds make a whole. And then root 8 times 2 is just 2 root 8. When you times the third of a whole number, you just stick them together. Now for the denominator, you got to treat this as if it was a double bracket quadratic problem, yeah? So it'd be root 8 times root 8, which is a whole 8. And then root 8 times 2, which is plus 2 root 8. And then minus 2 times root 8, which is minus 2 root 8. And lastly, minus 2 times plus 2 is minus 4. Now, just to simplify your life, you can literally just put everything in the bottom in the calculator. And if you did that, you'd be left with exactly 4. On the top half, however, you got to be a bit strategic. So for the 2 root 8, you can actually simplify root 8. But we're going to go ahead and put all of this part in the calculator, 2 root 8. And if you did that, you're going to get exactly 4 root 2. And we just copied 8 here. Now, thankfully, this is enough evidence, yeah? At this point, you can literally put this in the calculator, and you'll get your result of 2 plus root 2. And you're done. Okay, number 19. So B, C, D, and E are points in the circle. So here we go, B, C, D, and E. AB, this line of the arrow, is parallel to ED, this other line of the arrow. So they're both moving in the same direction. Angle ABE, which is over here, is 73 degrees. Work out the size of angle DCE, so DCE. In other words, this angle between them. Now, there's a super easy method to do this. Now, my tip is that you've got sort of like an incomplete shape. And what I would personally recommend is that this point C stops and then connects to E. You might as well go ahead and connect it all the way to B for a second, yeah? I'll explain why. Now, one useful tip is that every time you got a tangent that hits the circle, we can use a method known as the alternate segment theorem. Now, what this method tells us is that we know that at the angle at the other side of the chord is equal to the angle at the tangent. So in other words, this angle at tangent, which is 73, divided by chord, on the other side of the chord, i.e. the arrow coming off it, so this angle here, would also be the same of 73. Now this is going to be useful in a second, yeah, because you're going to pair this up with another theorem. So let's just keep a note of that, yeah. So angle on the other side of chords are equal at the tangent. Now, one thing to note is that looking at the shape, we have now a four-sided shape, yeah. We have something called a cyclic or cyclic quadrilateral. What this tells us is that when you got 4 points that touches at the ends of within a circle, like 4 points within a circle, you can form a quadrilateral. And at the opposite end of each point, like point C to point E, we can sum up these two angles to make 180. Likewise, you can say between D and B, we have another two pairs that add up to 180. Now, one thing to note here, let's look at point E for a second. And let's just fill this up before we use the method. We can say that because we got parallel lengths as well over here, we can say that this angle is equal to this angle too, because they're both alternate or corresponding, one of those two. We can now say that angle C, which is x plus 73 must add up to make 180. That is the cyclic quadrilateral rule. So these two pairs add up to make 180. That's it. Now we just solve for x and we got it. So you can have 180 equals x plus, and then 73 plus 73 is 146. Subtract 146 across, and you're going to get x value of 34 degrees. And that's it. That's literally angle DCE found. So here is a cube ABCDEFGH. Why did I say that? Where M is the midpoint of the edge GH. So M is bang in the middle. Find the size of the angle between the line MA, so M connecting to A, and the plane ABCD, so the ground. Okay, with these kind of questions, they're always the same. Now the good thing about this problem is that we're dealing with a cube, so every length is the same. And because they don't give us a length, well, we can just make one up. I'm gonna go ahead and just pick a length of, I don't know, 2. So this is gonna be a 2 by 2 cube. So 2 is all the way around. Now let's go ahead and draw the line they want. So they want the line from M all the way to A, and they want an angle between that and the plane. Now this is the bit where people get tripped up. To find the correct angle, all you have to do is basically draw a vertical line downwards. So again, this will be midway through this line BC, and then connect it across like that. Now you can kind of see that this line is trailing across the ground, and this line here is also perpendicular because this is vertically upwards and this is on the ground. Now all you want to do here is literally work out the length of, I don't know, one line. Let's say this diagonal D. Now to do it, this is just a case of 3D Pythagoras. We need to find the length around A to B, B to this midpoint here, and then this midpoint all the way up to M. And we got the lengths. We know this length is 2. This tiny length, which is half the distance, must be 1. So using 3D Pythagoras, we can say that A squared plus B squared plus C squared must equal D squared. So it'll be 2 squared plus 1 squared plus 2 squared equals D squared. Okay, and then just putting this in your calculator, you're going to get 9, so 9 equals D squared. So therefore, square rooting that, D is going to give you 3. Now this will be the diagonal length. Now, literally taking this right angle triangle outside the purple triangle, we're going to have a triangle that looks a bit like this. So we know that the diagonal length is 3. We're trying to find this angle between, and we got what's it called? A vertical length of 2. Now all you guys want to do is refer back to SOHCAHTOA and just pick the right pairing that we're going to deal with to solve this. So looking at this, we can see that opposite the angle we got the opposite, which is O, and this long diagonal length is the hypotenuse because it's always opposite the right angle. So we're going to deal with SO because we got an O and a H. We don't have adjacent or neither one. So therefore we can say that, remodeling it using SOHCAHTOA, we can say that we have sine of the angle equals the opposite O over hypotenuse 3. And then sine inversing this, you're going to get a simple result of 41.8 degrees. That's it, all done. Okay, number 21. So here is the triangle XYZ. Okay, the perimeter of the triangle is K, so the length around this is K. 5 plus Y plus X is K. Given that X equals Y minus 1, find the value of K. Show you're working clearly. Alright then, so it looks like they just waste space here. So you can just replace this X here with Y minus 1, yeah? So now we're working with less variables. Now, when you look at this triangle, we have 3 lengths and an angle. So every time you have 3 lengths and angle, we're going to end up using the cosine rule. It's always a choice between cosine and sine, but in this scenario, it's cosine. If you had 2 matching angles and 2 matching lengths, then it has to be the sine rule. So using the cosine rule, the formula in the book tells us that it's going to be a squared equals b squared plus c squared minus 2bc cos a, where a is capital, and the angle. Now to correctly identify what's what here, and this is important, because you've got one angle which is capital A, so this has to be here. That means the length opposite has to be little a. So the little a is going to be y minus 1, yeah? And now this means that the other 2 lengths, B and C, would be anything, 5 or y. So let's go ahead and substitute everything back in, yeah? So you got little a, which is y minus 1, so it'll be y minus 1 all squared equals b squared. So let's say 5 squared plus c squared, which could be y squared, minus 2 times b, which is 5, times c, which is y, cos the angle, which is 60. Now, what you could do, so what we have to do now is literally just simplify it as much as we can go. You see this little bit over here? This part can easily catch you off. In your calculator, just write 2 times 5 times cos 60. And when you do that, you're just going to get exactly 5. And then put the y next to it. Now for y minus 1 squared, this is the same as y minus 1 times y minus 1. When you got a squared bracket, it just means there's 2 of them. And now to expand this bracket, you just times term by term. So y times y times minus 1 and y, and minus 1 and minus 1. So doing everything then, so multiplying that out, we're going to get y squared minus y minus another 1y plus 1. And it's going to equal the right hand side, which is all of these lot. So 5 squared is 25 plus y squared minus 5y. Alright, so we're almost done, yeah? We're almost done here. Just to make your calculation a little easier, we got y squared on both sides with equal signs, so we can cancel them out. Now, collecting like terms on both sides, we're going to have minus 2y plus 1 equals 25 minus 5y. And now let's move all the y's to the left and the non-y and the numbers to the right. So adding 5y across, we're going to have 5y take away 2y, which is 3y. Minusing 1 across, we're going to have 24. And then dividing this by 3, you're going to get a y value of 8. Now, because you know the value of y, which is 8, to get x is just 8 minus 1, which is 7. So x is 7. So 2 things are solved. Now finally, to find the perimeter of the shape, so let me just tidy this up a bit. We just need to literally add up all these lengths. So it's going to be 5 plus y plus x. And we know what that is. It's going to be 5 plus 8 plus 7. And therefore, that's going to give us a total length of... Oh my God, I'm so slow. So 15. So give us total length of 20 centimeters. All right, number 22. So you got A, B, C, D, E, F is a regular hexagon. Okay, so it's regular meaning all the interior angles are the same. Now ABX and DCX are straight lines. So let's see, ABX, so this long line across and this long line going down diagonally are straight lines. Now the direction from A to B is the vector A. So this means that we have to represent this line by the little vector A. And going from B to C, so this direction is represented by little vector B. Now before we read on more, every time we got parallel lengths, we can put the same thing. So we know that A to B is going by the vector A. This is moving in the same direction, so it's also little a. And this vector here is also parallel to B to C, so that's going to be little b. Now, we don't make any assumptions about this line here, because we don't know if it's the same length. But we can probably figure out, and I'm guessing it will be. So they want us to find a vector from E all the way to X in terms of A and B. Okay, so that part is not too terrible. All you really need to do now is firstly figure out what is the interior angle of a regular hexagon. So you might know about heart, but if you don't know, we always use this formula. We say that the sum of the interior angles is always the number of sides minus 2 times 180. So that's the sum of the interior angles, yeah? And now we know that a hexagon is a 6-sided shape, so it'll be 6 minus 2, which is 4 times 180, and that gives us 720. Now, if all the sides add up to 720 degrees and there's 6 sides, if we divide the 720 by 6 to get one angle, we're going to get exactly 120 degrees. So this tells us that all these angles must be 120. Now, the good thing is, the reason why I'm doing this, by the way, is that I'm trying to figure out if this is an equilateral triangle. Because if it's an equilateral triangle, this would mean that this length would be the same as this vector A, which would be helpful. If they were different lengths, then it's not a regular shape, so we can't assume that it's the same length. Okay, so let's figure that out. So we know that angles on a straight line adds up to 180, so this must be 60. This is also 60, and this is of course 60. So this is 100% an equilateral triangle. And because of that, we can now say that this vector must also be the same as that vector, because they're both the same size. If this length was twice as long, then this would be 2a, but it's not. Now, to be honest, now we're actually almost done here. So what we want to do now is basically try and make an expression for this kind of other diagonal vector, because we only know the root going from this side of the diagonal, but we don't know about the opposite end. So we're trying to figure out what these kind of vectors could be. Now, to work them out, an easy way to do it is to really think about how to go from X to C using any possible map. And to go from X to C, we can go through this vector, so we can go through minus a and then plus b. So minus a plus b, or b minus a. That's how you can go. So with vectors, you can take any possible route as long as you get to that position. So because that moves in the direction of b minus a, this is also b minus a, and this is also b minus a. Okay, so now we got every single known vector. We can finally figure out how to go from e to x. Okay, so let's put a map down, yeah? So we can go through all of this route, up here, and then up here as well. Now to do that, let's have a look. So we're going to travel from a first, so we can say that e to x must equal a first plus, so you notice how we've got an arrow facing the opposite direction. So if you're going opposite, it'll be negative b minus a. So we'll put minus sign. And then we're going to go through another minus b minus a. So minus b minus a. And now we just collect like terms. So opening the bracket carefully, we're going to have a minus b plus a minus b plus a. And then therefore we're going to have, let's see, a plus a plus a is 3a. Minus b is minus 2b. And that's the vector they want. And finally, number 23. Ooh, let's do it. So the function f is defined as fx equals the square root of x squared plus k squared all over x for positive values of x, where k is a positive number. Now, part A, find the value of p for which the inverse function at the point p equals k. Alright, so what this is telling us is, firstly, we need an expression for the inverse function. So let me just change the color of my pen. Now, to find an inverse function is a very, very easy way. Just replace all these letters of y, yeah? So just say, replace fx with fy. So it's going to be the square root of y squared plus k squared over y. And now we make this equal to x, alright? In this case, because they want us to find the value of p, we're just going to replace this x now with the letter p, because that's what they want. So let's go ahead and simplify all of this, yeah? We have to make y the subject. Now, let's see, what do we do from here? So what we could do is clear the fraction, so multiply y across. You're going to have the square root of y squared plus k squared equals p times y. To get rid of the square root, square both sides, so that cancels. And both of these are now squared. Now, what we could do is move all the y terms to the left and the non-y terms to the right. Because p squared is attached, we move them both across, so it'll be y squared minus p squared y squared equals, and then move k squared across, so it'll be minus k squared. Now, what you want to do here is factorize the y squared, yeah? Because you want to isolate it. So it'll be y squared factorized, you get 1 minus p squared equals minus k squared. And now lastly, you want to divide 1 minus p squared across to get rid of it. So it'll be y squared equals minus k squared over 1 minus p squared. And yeah, almost done. And now we just square root to make y the subject. So you got y equals, oh yeah, little tip, flip the position of 1 minus p squared. So it'll be p squared minus 1. The reason why, then this part will be positive, k squared. It's the same result, just a nice little fancy way. And then yeah, put the square root sign. You literally found it. So y is basically the inverse. So we can replace this with f minus 1p. And we also know that this expression is now equal to k. So alright, so here's round 2. And you know what, all this for 3 marks, nah, that's too small. So to solve this one now, for p, we have to clear the third. So get rid of the square root sign, so square both sides. You're going to get k squared over p squared minus 1 equals k squared. Now, let's have a look. So now we can swap positions. So we can times p squared minus 1 across. So we get k squared equals k squared times p squared minus 1. Divides k squared across, so you get k squared over k squared equals p squared minus 1. Oh my god. Now k squared over k squared cancels out. You just left with 1. So let me just put that as 1. And lastly, now you can plus 1 across. So you can get 2 equals p squared. And then you square root both sides, you get p equals plus minus root 2. Now, I think we're done, but we're just going to double check. Okay, blah, blah, blah. Where k is a positive number. Okay, so, hold on. Okay, oh yeah, because k is a positive number, that means p would also in turn be a positive number. Because it has to be to get an actual positive value of p. But anyway, we're just going to say, therefore, p is root 2. Oof, this was a long question, wasn't it? Okay, now we're on the final part. So the function g is defined as gx equals x squared for positive x values. Now, given that gfa equals k, in other words, this is the composite function where f enters g for k greater than 1, find an expression for a in terms of k. Okay, so for this question, this literally tells us that we need to put the function of f inside the g function. In other words, replace x squared with the function squared. So where's the function? So f we know is all of this. So let's go ahead and copy this down for a second, yeah? So fx equals the square root of x squared plus k squared over x. And now it tells us that we're going to put this inside of g. So we say therefore g fx. So we're going to take it step by step here. We know g is x squared, so it'll be something squared. So it'll be all of this root x squared plus k squared over x squared. And simplifying this further, by the way, when you're squaring a square root, they cancel out. So you're left with x squared plus k squared, and then you square the x, you get over x squared. So that's what they want. That's g of x. Now let's answer the question. It says given that gfa equals k, so in other words, replace the x of a and make it equal to k. So we're gonna have, let's write it down. So gfa equals a squared plus k squared over a squared. So remember, all the x's become a, and that's supposed to equal k. Find an expression for a in terms of k. Oh man, my tongue. So just like the inverse function, you're going to do a lot of steps, yeah? So let's try and minimize it. So first things first, clear the fraction. So times a squared across. We're going to get a squared plus k squared equals ka squared. And now we want to make what the subject? We want to make a the subject. Okay, that's when it says find an expression for a in terms of k. All right, they go right here, a equals. So we need to move all the a terms to the left and non-a terms to the right. So because this is glued together, move it to the left. So you got a squared minus k squared. And then move plus k squared across will be minus k squared. Then from this point on, you can factorize a squared. So it'll be a squared 1 minus k equals minus k squared. And then just like the inverse one, divide 1 minus k across. So you got a squared equals minus k squared over 1 minus k. Oh man, tongue twisters. And lastly, just like a nice little fancy trick, we can just rotate this position around. So it'll be a squared equals positive k squared over k minus 1. Again, when you do this, it just switches the sign at the top. I don't know if it's important, probably not. And then lastly, square root this, and you're going to get a equals the square root of k squared, which is k over root k minus 1. And I think that's it. Is it positive? Yep, k is positive. So yeah, it looks good to me. I think this is the final result, and we leave it here. Oh man.